Hello grade 12 A-level students. Right now we are going to continue the last part of amino acids. Organic nitrogen compound, it is 27.7 electrophoresis of amino acids and peptides. The principle of electrophoresis is best explained by looking first at how the simple amino acid, glycine, behaves at different pH values. This is because of the amphoteric properties of amino acids. We know that amphoteric means it can react with alkali and acid. If we have a solution of amino acid in water, the average charge on the many molecules of amino acid in the solution depends on the pH of the solution. The pH at which the net overall charge is zero is called as the isoelectric point of the amino acid. For glycine is 6.07. So the average charge on the many molecules of amino acid in the solution depends on the pH of the solution. The pH at which the net overall charge is zero means there is not positive. It is not positive or negative. Then it is called as isoelectric point. For the pH of glycine is 6.07. In addition of acid and addition of the acid, this glycine will at pH less than 6.07, it is the alkali, the NH3 plus. And then when it is negative, COH, it is at the pH of more than 6.07, and then the isoelectric point is this one. It is not forming, it is forming exactly not positive, not negative, it is zero. Why is it zero? Because in here one positive, in here one negative, so will eliminate each other. In solution pH less than 6.07, the average charge on the glycine molecules become positive. It attracts to the positive side. And then at pH more than 6.07, the molecules become negatively charged. Why is it glycine is chosen? Because glycine has the active site of only H, only hydrogen. Okay, that's why it is called. That's why it is used to explain the concept of electrophoresis. Depending on the site groups, different amino acids have different tendencies to form cations or anions in solution, and so their isoelectric point will occur at different pH values. The more basic ones, such as lysine, which have tendency to form cations if dissolved in water, will have their isoelectric point at a more alkaline pH than most. On the other hand, the acidic amino acids such as aspartic acid will have their isoelectric points at more acidic pH at most. So let's see here. Glycine, the active, the R group in the amino acid is H. So isoelectric point is 6.07. It is close to the neutral point. While this one, lysine, it contains NH2. NH2 is an amine. Amine is alkali. So the isoelectric point is at 9.74 pH. And then the aspartic acid, because the R side contains carboxylic acid, it is an acid, so the isoelectric point is at 2.98. If all three amino acids were dissolved together in the same buffer solution, what buffer solution is, I'm sure you still able to recall. The buffer solution kept at 6.07 on average, the molecule of glycine would be electrically neutral. And then the molecule of glycine would be positive charge. And then the molecules of aspartic would be negative charge. Why is it like this? Because as we can see in the structure here, lysine, the positive ion, there are two positive ions and one negative ion. So the positive ion overcome the negative ion. Similarly with aspartic. In aspartic there are two negative ions and one positive ion. So the negative ion overcomes the positive. Okay. Next, if a drop of buffer solution at pH 6.07 containing these three amino acids was spotted onto gel-coated plate immersed in a conducting liquid and a potential difference applied, the lysine would move to the cathode. Aspartic acid would move to the anode. Okay. And then while the glycine having no overall electric charge, it would not move at all. It is written here, lysine would move to the cathode. As we can see here, electrophoresis, this is how it looks like. This in simple diagram. So lysine will move to the cathode. We know cathode is in electrolysis, cathode would be called as negative because it will be called as negative side. Why negative side? Because it contains positive charge. Then the positive will attract to the negative side of the battery. And then also the aspartic acid will move to the anode. Anode is the positive side of the battery. Let's see here. This is the main concept. So in 6.07 buffer solution, look at here, aspartic has two negative ion. So these two negative ion will attract to the positive side of the battery. That makes the aspartic is attracted to the anode. While the lysine here contains two positive ions. These two positive ions, it means the molecule become positive. The positive will attract to the negative side of the battery, and the negative side of the battery is called cathode. This separation of mixture in an electric field is called electrophoresis. The electrophoretic mobility depends not only on the average charge but also on the size and shape of the molecule. So the velocity, how fast the molecule move, depends on the electric field where the voltage applied, and then the average charge in this positive or negative, and also the frictional resistance. The frictional resistance is composed of various factors. The size of the pores in the gel support. The smaller the pores, the slower the sample moves. The shape of the molecule. The larger spiky molecules travel slower than small spherical ones. And then the size or molecular mass of the molecule. The larger molecules travel slower than smaller ones. Okay, this concept is we have to keep in our mind. In A level, they are going to ask us in which side the molecule will move, will attracted to. Is it to the cathode or to the anode? Depends on the nature of the amino acid. Okay, so this is the concept of electrophoresis. Now, other factors that affect the speed at which the compounds of a sample move during electrophoresis are pH of the buffer solution, average number of charged group or an electrophoretic or amphoteric molecule depends on the pH. As the pH increase, the average charge become less negative or become less positive or become more negative. And the temperature of the apparatus, the speed of movement increased with temperature. Why increase with temperature? Because the higher temperature gives more energy for the particles to move. Electrophoresis is used regularly to separate and identify not only mixtures of amino acids but mixture of peptides obtained from proteins and even mixtures of proteins themselves. By this means, abnormal proteins can be identified in patients suffering from genetic disorders and possible treatments monitored. Now let's see the synthetic polyamides, or called nylon. Synthetic polyamides are important class of manufactured polymer. They are condensation polymerization process. Condensation polymerization is different from addition polymerization. Addition polymerization contains the same type of monomers. The monomer must contain double bonds. But in condensation polymerization, there are two different monomers. These two different monomers, both of them will undergo condensation process to produce a small molecule. The linkage can be amide linkage or ester linkage. Since this is amide linkages, so it will become an amide linkages. There is an amide to link between one molecule with other molecule in the polymerization process. In this one, diacyl chloride can also be used in a reaction similar to the preparation of simple amides. This is two different monomers. This is diamine. This is diacyl chlorides. So when these two monomers react, they become polymer. What is the small molecule that given out? It is the HCl. Okay, so this is the last part of the amino acid. After this, we are going to have exercises, and then we will continue to another chapter, chapter 28.